ठीक है ना, ऑडियो ऑडियो का ठीक है ना, तो मैंने शुरू कर दिया। Dash, how to share the video?
क्या वो शेयरिंग ऑप्शन में ही होगा सर?
वीडियो का नहीं है ऑप्शन?
है ना, है सर, सारा सारा स्क्रीन में जो भी स्क्रीन में आएगा सर, सब आएगा सर,
तो मेरी फोटो नहीं आएगी?
सब आएगा सर। अभी जैसे आपका वेलकम है, जो भी पीपीटी शेयर करेंगे, वीडियो शेयर करेंगे, सारा वो स्क्रीन
मेरी फोटो आएगी कि नहीं आएगी?
आएंगे सर। आपका वीडियो ऑन कर लीजिए, आपका वहाँ पर वीडियो ऑन होगा सर, ऑडियो वीडियो ऑन ऑडियो कर लीजिए सर।
कहाँ पे, वही मैं पूछ रहा हूँ, कहाँ पे ऑप्शन है वो?
वो दो जैसे नीचे हमारा आता है ना सर, म्यूट एक होता है, म्यूट होता है, एक स्टार्ट वीडियो होता है, एक साउंड ऑडियो के दोनों अलग अलग ये आइकन है सर, इसका दिखिए सर नीचे।
एक सेकंड, कहाँ पे नीचे?
हाँ नीचे सर, नहीं नहीं, जब भी आपको वेबएक्स में जाइए सर, वेबएक्स में जो आइकन है ना, वो नहीं सर, सर वो वाला जो वेबएक्स का आइकन है ना, हाँ उसको करिए सर। तो इसमें आपने ज्वाइन किया ना सर, इसको बंद करिए सर, इसमें आप ज्वाइन किए थे ना।
एक सेकंड, हाँ
हाँ इसको भी कैंसिल कर, वेबएक्स जहाँ पर है सर, वेबएक्स का अगर ऑडियो वीडियो दो होगा सर आपका।
कहाँ पे होगा?
पुष्पेंद्र जी, हेलो पुष्पेंद्र जी,
यस सर।
सर का थोड़ा हेल्प करो, सर का वीडियो नहीं आ रहा है, जो सर का ऑडियो तो आ रहा है, वीडियो का
नहीं सर, आप बोल रहे हैं वहीं से आएगा, तो डायरेक्ट से ही आएगा सर।
सर नीचे है सर वेबएक्स का
सर यहाँ पे म्यूट और स्टार्ट वीडियो ना, स्टार्ट वीडियो कीजिए आप सर। आपका डायरेक्ट वीडियो स्टार्ट नहीं है, बैक कैम स्टार्ट कीजिए अपना बैक कैम।
आपको स्क्रीन दिख रहा है ना? स्क्रीन में कहाँ पे है?
अच्छा स्टॉप शेयर करिए सर, स्टॉप शेयर करिए, बता रहा हूँ सर, स्टॉप शेयर करिए सर।
एक सेकंड, अच्छा यहाँ पे है ये
सर
नहीं होगा?
नहीं सर, स्टॉप शेयरिंग कर लिए सर, मैं बता रहा हूँ।
एक सेकंड, यहाँ पे होगा ना, व्यू कैमरा?
हाँ ये सर
Okay, so right, so I should say okay or what?
ये सर। सर जो आपका सर शेयरिंग ऑप्शन को सर क्लोज कर लीजिए सर, स्टॉप शेयर कर लीजिए, तो वहां से आपको स्टार्ट वीडियो होगा, देन अगेन शेयर कर लीजिए सर।
एक सेकंड, अच्छा स्टॉप शेयरिंग करके
अभी सर देखिए सर, आपका पास म्यूट होगा, आया होगा, म्यूट और वीडियो दो होगा सर।
ऑडियो एंड वीडियो, हाँ
हाँ
यहाँ
उसको
पे।
हाँ इसको ऑन कर दीजिए सर, अभी शेयर कर दीजिए सर। हाँ अभी अभी दिखाया गया सर, अभी सर अभी पीपीटी से ओके सर।
I'm really sorry, it's all you know, because normally we work on Zoom and Google Meet, so I downloaded WebEx, but was creating some problem anyway. So now let me share. Okay.
yes sir, perfectly fine sir। इसको सर पीपीटी प्रेजेंटेशन मोड में आ जाइए सर, फुल मोड में। यस सर,
Right.
यस सर, ओके सर,
Okay, great.
थैंक यू सर।
So, friends, welcome and very good morning to all of you. And we are really very sorry because some technical problems I was facing. And thanks, Manoj, and your team helping me out to come out with, you know, these proper and smooth presentation. Okay, so friends, let's start. and start with God grace and blessings. We start our day. So, with God grace, we hope that we will have happy learning in these sessions. Right. So, what do you see here? It's a black box. And how you feel when something totally blank and black comes before you? We don't feel very comfortable with it. What we are looking at is, something light, and that's important for us. The moment you start having light, the darkness goes away, and that's the purpose of our learning. We have to remove the darkness of ignorance from our mind and bring in the light of the knowledge. So with this, I hope this workshop provides you an opportunity to move from darkness to light. And I'm really happy that the organizers have taken all the pain to, help us in shedding our ignorance and bringing in a lot of light and bringing a lot of knowledge to us. So friends, enjoy happy learning today. And of course, you have to learn with understanding. So again, welcome to the session on introduction to the panel data analysis. So today's sessions will be the sessions when you people will be taught a lot of energy and a lot of concentration. So you have to sit with concentration, with attention, and I hope your cooperation will be highly appreciated. And please, my request to all of you is don't hesitate in asking questions. Anytime, any query you have, please, you can put it in the chat box, or I think, I don't know whether the organizers have allowed you to unmute yourself and talk to me. But you have to ensure that you are understanding what we're talking about, and you have to ensure that you have clarity, and clarity, nothing else, clarity. Okay, so please don't be afraid. Questions are always welcome. Don't think that your question is a silly question. Don't be afraid of that by that particular feeling. Okay. And I can see your responses in the chat box, and I can also reply to those responses. But make sure that you understand what we are talking about. That's very, very important. Organizers, are participants able to talk to me if they want? Is that possible?
Yes, sir. They can unmute themselves and talk to you.
Okay. Chaitanya, right?
Yes, sir.
Chaitanya, what's your background?
Sir, I am a research scholar under Dr. Manoj Kumar Das in IIITM Gwalior. and my area is artificial intelligence and consumer behavior.
Okay. So this is suddenly, it's time to start something new and trust the magic of beginnings. And I hope all of you are ready for a start. Okay. So welcome again to the sessions on panel data. So friend, let's dare to enter the word of the panel data that's important for us. But first a quote. Friends, show me what I can do. Show my strength and motivate us to do what we want to do, and first teach me what I should do. And you might be wondering why I'm sharing, this particular quote with all of you. Friends, show me what I can do. First teach me what I should do. And who is your best friend in econometrics? Anybody guess? Anybody? Anybody who can tell me what is that you would like to say in econometrics?
Myself. I am the best friend of myself.
Myself.
Yeah.
I'm talking in econometrics. So that Mr. Naik, I'm
Data,
talking
sir.
of huh?
Data.
I love data. I love econometrics. That's why I'm speaking, sir. I am best friend of econometrics.
Okay, okay. But what is within the econometrics, which is friend? Within econometrics. Mr. Naik, I'm not asking whether you are a friend, you are not a friend. Okay, that's not the question. The question is within econometrics, what is that? Which everyone like to say. Everyone would like to work with that. Stats, that's what Imran Khan said. Anybody guess? Think. Normality of the data. That's what Jen says. No. Normality, I tell you, is not a bigger challenge because if you take the large sample, then using the central limit theorem, you can justify normality. So normality, I tell you, is not a big challenge. It is OLS. Economic theory and maths, okay, no, it's OLS. And you know why I'm saying OLS? OLS means ordinary least square estimator, because they are the blue estimators, the best estimators. Simple, intuitive, best. And therefore, whenever I get an opportunity to use OLS, I love to use OLS. Isn't it? OLS is something which is very, very dear to us in econometrics. We love to use OLS whenever we get an opportunity. If we are not in a position to OLS, then we are a little bit frustrated why we are not able to use OLS. So I will say that OLS is the, friend. Is my voice low?
Sir, you're audible.
Organizers, is my voice is low? Because
No, sir, you're properly audible.
okay, thank you. And OLS tell us what I can do in econometrics and show, the strength of the econometrics. And what is the most important greatest four in econometrics? Yes, Nayak. Nayak. Chaitanya, people are saying my voice is low. I don't know.
Sir, your voice is clear. I'm asking the participants to check their own volume. Maybe it's a problem at their end.
Okay. Yes. What is the greatest enemy in econometrics? Dr. Naik, can you try with that? Imran, Udyan, can any one of you try? What is that greatest foe? I mean, what is that which always create a problem? You wish, you don't wish, but this is something which will always be creating problem. Udyan, errors. Yes, error is the greatest foe. But then why it is greatest foe? Why I'm saying it's my greatest enemy? The reason is, the behavior of error term is totally random, and we never know how it will behave. And to, discipline the error, you will find most of the assumptions are imposed on the error so that it behave in a disciplined manner. Again, it may have hidden information, but if it had hidden information that it's good for me, I can make use of that information. But if it is not having information, I don't know whether it has information or not, but its behavior is totally unpredictable. We don't know how that error is going to behave. And if it starts behaving in undesirable manner, it will create all problems in your estimates. Okay, so error term is something which is needed to be disciplined. We have to control its behavior, and for that we impose assumptions on it. And if you see the assumptions, they are all about error term. The mean of the error term should be 0. Variance of the error term should be constant. No autocorrelation among the errors. No correlation between the independent variable and the error. Error term follows normal probability distribution, and we are assuming that x's are given to us. They are non-stochastic in nature. And no perfect collinearity between the independent variables. So barring this assumption, all assumptions are on error term. And if any assumption is not true, result will be your estimate may not be blue. And that's what exactly, it creates problem. Okay, anyone having any question about the assumptions? I hope all these things are clear to you. And if these assumptions are not true, then what is to be done? That's what this error term teaches us. The behavior of the error term teaches me what I should do in econometrics. Okay, should I go for some other estimator? Should I transform my data? What should I do? That will depend upon, what is happening to the error. So OLS is my first love in econometrics. I will always like to use it. Error term, spoil that love and creates problem for it. And also teaches us what should you do. So always try to use OLS unless the error term becomes the culprit and spoil the things. And why I'm having this discussion with you? Why this discussion? I have a reason for having discussion about it that you will understand gradually when we proceed further. So the whole fight in the panel data analysis is how to fight with the error term, which is spoiling the quality of the estimates. And that's one of the biggest challenge which we have. And that's the motivation why I started with this discussion, that error term. Can you imagine why error term creates problem with the panel data? Anyone? Why do we need separate, totally different kind of techniques? Why can't you use OLS in panel data? I mean, we must understand why not OLS in panel data? Why do we need it separate, totally different kind of discussion? Yes, Nayak. Mr. Nayak, are you there?
Yes, sir. Yes, sir.
Yes, Nayak.
Voice now. Yes.
Why do we need special techniques for panel data? Why not OLS?
I feel some parametric issue, sir.
Which parametric issue?
I'm not sure, sir.
Udyan is saying then error term is having information. That's not what we do here, that you may use in the time series. But yes, you are absolutely right when you said endogeneity problem. We have other problem, but the most serious problem is endogeneity problem. So we have to understand what it is, why it is, and how to take care of it. But first up, something very simple to begin with. And do we see any relation between age and the blood pressure? And for a researcher, we have to prove or disprove only with the data. In God we trust. All others have to bring the data to prove it. So we make a model that blood pressure is equal to alpha plus beta, age plus error term, and we run the regression, and that's the fitted line on a scatter plot, and that's the result which we get. And this is coming to be significant. And if you see, the R square is almost 61%. Chaitanya, what do you think? It's a good model or a bad model? Anyone?
Sir, I think it is a decent model because if coefficient of determination 61%, it would mean that almost 61% of the variance in Y is explained by the independent variables which we have taken in this model.
Right. So should I report the result or should I take a relook on to it? Dhyan, please. Okay. Later on, it was observed that weight is also an important factor that is impacting the blood pressure. And we find that both are significant. R square is now 68%. So we have a problem. Which result we should use? Should I go for this? Should I go for this? Any one of you can respond to it, no problem. Or even the organizers can respond to it.
Sir, we'll see where the AIC criteria is lowest. That one we should.
Sudeshna,
Yes, sir.
were you there
Sir,
in some of the program? Because
Sir,
just
yesterday only it was discussed. That is why I'm telling that
yes.
the model in which AIC criteria was lowest.
Okay, so that model is a good model.
Yeah,
Any
with
problem?
greatest R square.
Any problem here? Udyan, any problem here?
Sir, the AIC criteria.
AIC criteria, Sudeshna, is not an issue.
Okay.
The estimate which you get here, is it blue?
Use the second model, sir.
Why second model? Shahid. Yes, Shahid.
Because
Why second
sum
question?
of squared residuals has come down, so that we can say that error has come down because some other variable is affecting.
Does it mean,
as you can see, the coefficient of
that you
age.
go on adding variables? No, it's okay. But my question
Excuse me,
is,
sir, you are not audible.
Is this estimate of the age coefficient we get, is it a blue estimate or not? That's my question.
See, you are not audible. Your voice is breaking, sir.
Is Chaitanya, is my voice breaking?
No, sir,
Yes,
you
sir,
are audible.
voice is.
It
Maybe
just
I
happened
might
for
have some
few
network
seconds.
issue.
Yes.
Yeah, it
Dr.
happened in
Sai,
between for a few seconds only.
okay. Is this a coefficient of age, is a blue estimate or not? That's my question. Should you report this? If you do it, are you doing some mistake? Suppose I don't report this at all. I report it. Am I creating problem? Is my results are acceptable?
So we'll do the residual diagnostic check and then maybe we will decide.
That assuming all assumptions are true, except one or two assumptions, but otherwise residuals, no heteroscedasticity, no autocorrelation, normality, everything is there except one or two assumptions. So then can you imagine, it may not be intuitive, okay. Right, the estimate which you get here will not be blue. Why it will not be blue? That's something which we have to understand. If we omit a variable from our model which is of significance, then it creates a problem which is called omitted variable bias. And that omitted variable bias make my estimates biased. That means the estimate of this module will be biased. And therefore, I should
because the
not use it.
specification is not correct.
Pardon? Dr. Shahid, what you said? The specification is not proper. Is that you said?
Model specification not correct. Yes, sir.
Right, right. And
Because we have some
of that,
other variable which is significantly affecting our dependent variable, but we have not included that one.
right. So we have to understand if you omit a variable, what are the consequences of it? Assume that this is my true model. X1 is my age. X2 is my weight. Instead of this module, I estimate this module with age only. Then this will be my estimates. And what is it? Manoj, you can also participate if you wish in the discussion. What is it?
Okay, sir. Okay.
What is it? What is this term? What is this term? This is giving me covariance.
This is the product of deviations.
Right. So
of
that will help
X1 from mean and X2 from mean.
That will give you the covariances,
Yes,
right?
Yes,
Yes, so you're absolutely
correct.
right. And if this covariance is 0, what will happen? This covariance is 0, what will happen? No biasness. Because this will become 0 altogether. So you will not have biasness. Okay, so is omitting variable always create a problem? The answer is no. It will create a problem only when it is correlated with one of your independent variables. Now let's try to understand intuitively. Same example I take. You have a BP, you have age, right? Weight. If you run model with BP and age, you know what weight will do? Weight will sit in your error term. It will be hidden in the error term. Error term में घुस के बैठ जाएगा ये. It will reside there. And since weight and age, they are correlated, then which assumption is violated of OLS? Which assumption? The covariance between
Multicollinearity.
no, X and the
Strict
error term.
exogenity. Strict exogenity assumption is violated.
Yes,
Because here we have endogeneity problem.
yes. So whenever you have omitted variables, you will find a problem, and that will result into biased estimates. So if they're not correlated at all, for example, then you may not get the biased results. But it's very difficult to prove that what is not in the model, whether it is correlated or it's not correlated, very difficult to prove that.
So may I ask a question? So may I
Yes,
ask?
Gaurav.
Right.
Gaurav,
So,
please go ahead. Don't be afraid. Please go ahead.
yeah. So, sir, I was doing an analysis and I found, theoretically all the variables, they should be related with the dependent variable. But when I remove one of the independent variable, then the performance of the model increases, right? So omitting a variable actually improves the performance of a model. Now I also understand that there must be some sort of correlation between the independent variable, but which variable to omit, which variable to remove in that scenario? So some guidelines.
Gaurav, if you take a model, suppose I take a model, right? Y is equal to alpha plus beta 1 x1 plus beta 2 x2 plus error term, right? You are saying x, you are dropping x2, right?
Right, sir, right.
So in what way you say the performance of the model has improved?
Right, in terms of adjusted R square.
Huh?
In terms of adjusted R square.
You mean to say the adjusted R square has gone up, right?
Right, right.
Okay. So what is the problem then? What is the issue?
Right. So, yeah. So just now we're discussing, maybe we have omitted some variable. That's why we should not be choosing a model. But what I have observed, maybe, the specification I'm making is not right, because when I remove one of the variables from the model performance improves actually.
Yes. So what does it mean? Why it is it proved that this may not be significant? It may not be correlated.
Right, right.
So problem is if it is correlated, if the covariance is there, then it creates a problem.
Right.
Okay, otherwise it will not create a problem.
Okay, sir.
So I really don't know whether what is that particular variable and how that particular variable is behaving. So because since you are saying insignificant, that means it may not be having any correlation with y. Okay, so x1 is correlated with y, right?
Okay, sir.
And x2 is not correlated with y. So x2 may not be correlated with x1. So if x2 sits into my error term, I don't see endogeneity problem in that case.
Okay, sir. Okay.
I mean, what is required? Little bit, if I take you back to this example, you have age, you have weight, right? Okay, both are impacting my blood pressure, and they are also correlated with each other.
Right, sir.
In your case, it might be possible that this connection is not there. That's why it is not coming to be significant and it has been thrown out from the model. Might be, I'm not sure about what you said. Okay, Manoj, can I solve this problem by using structural equation modeling? Anyone? Can I solve this problem using structural equation modeling?
Yes, sir.
How can we do that? Yes,
Sir,
Sudeshna, please. How can we do that?
Sir, taking principal component like eigenvalues of the factors, and we take a
Sudeshna,
principal.
don't make your
Yes, sir.
answer so complicated. We don't know what is eigenvalue and all that. It's a simple
Sir,
problem.
we'll find out a principal component which is
But
there
why do
between
you
age
want
and
it?
weight.
Why do you want to have principal component? Are you reducing the dimensionality of the problem? We don't want that.
Yes,
I
sir.
mean, simple. You have blood pressure, right? You have age, you have weight. That becomes your structural equation model. Estimate it. You do it through that, you do it through regression. Result will be exactly identical. No difference. But we don't prefer to use the structural equation model. We go for regression.
Yes, sir.
Anyway, that's slightly divergent. Yes, Gaurav, still you have a doubt? Or?
Okay, sir, I will try to look into it. I'm not familiar with structural equation modeling, sir.
No. I didn't talk about that. About your problem.
Yeah, sir. I have some idea. I'll further explore into it.
Okay. So learning is we have to take care of the omitted variables which are correlated. And panel data will help us in taking care of this kind of a problem. So what if we are not in a position to observe omitted variables? Can we do something in this regard? Again, if I know some omitted variable, I can add into my model. But if I'm not aware of it, then what should I do? तब क्या करेंगे if you are not knowing कि there is a variable which you have omitted? Neither you have the information about it, nor you have the understanding about it. Literature review, remove their effect is a solution. Removing, but then I don't know anything about those omitted variables. So no question of removing. Yes, literature can help you in identification, differencing. Okay, right. So anyway, then I will come back to that differencing thing later on. But one thing is very clear, I have no information, so I cannot include in our model what is to be done. That is something we are going to learn in this particular session. We have to learn it. Okay, so we can answer this question, but we have to wait for some time. Any quick question if you have before we go ahead? This is all something which is preparing our background to take up the challenges of panel data. Let's see what next we are going to do it. Gaurav, something for you. I checked it very thoroughly, said the computer, and that quite definitely is the answer. I think the problem, to be quite honest with you, is that you are never actually know what the question is. So many times we don't know what is the problem. And we blame data, we blame softwares, we blame computers, but real culprit might be our understanding about our problem. We don't understand our data, we don't understand our problem, okay? Those could be the problems, but I mean, I don't think software and computer and the data may be a problem. So take a pause and think what we have done so far. Just quickly recall the things, whatever we have discussed. So I trust that now we are capable of taking challenges of panel data analysis. So let's first define what is panel data. Panel data is set having cross-sectional data as well as the time series data. Okay, so it's a two-dimensional kind of a data where you have cross-section or you can call it a space and the time. And whenever we define or describe panel data, you will find it has two subscripts, one for cross-section and another T for time. Cross-sectional observations you can arrange in any order, whatever you want, but time has to be ordered in a particular specific manner. So cross-section may not be ordered, but this should be ordered. Many times we find that people are using a panel data set and pool data set interchangeably. Okay, but we do make a difference. And the difference is to illustrate that difference. Let me take an example. 500 companies, 10-year data, about profit. One example. Another example. Class 12 students marks over last 10 years. Do you see a difference between the nature of the data?
So can I ask a question?
Yes.
That is the second example, an example of panel data. Because, sir, we are taking, I don't think it is cross-sectional data because we are collecting data only from class 12 students. It is an example of time series data because we are
So
collecting data over 10
the
years.
class 12, you have 50 students, right?
Right, sir.
Is it not cross-sectional, 50 students?
Okay, sir, understood.
So you have, I mean, if you see this structure, it's like this. Students 1 to 50, and then you have the time, say 2010, 2011. Okay. So it's a panel. But there is a very fundamental difference. I don't know whether you people have catched it or not. Dr. Shabir, can you try? Sudeshna, can you try?
Sir, I
Yes,
think
Vinay.
in the 500 company, this is the there are a lot of company. From that we took 500 company for the 10 year. But for class 12, we took complete all the student, complete student of 10 year. I think this is the only difference. And first one is the kind of pool data, and second one is the panel data.
No, it's reverse.
Okay.
Anybody else?
Sir, like if in the first case it was Nifty 50 companies, then maybe we could have called it a pool.
Sudeshna, सुधर जाओ. इतने complex मत बनाओ. Nifty 50 कहाँ से आ गया?
नहीं
It may
नहीं
be any
मतलब
500. Any 500.
yes sir.
You know, the difference is you have same 500 companies. Same. Okay. But here, the students are changing every year. I will not have the same student for the last 10 years. My cross-sectional unit is changing. Do you see a difference? Same 500 companies data for the last 10 years. But here, we are having different students every year.
Sir, first one is panel and second is pooled.
Yes. Because I'm not looking at the same cross-sectional. My cross-sectional units are changing because of the nature of the data which we have. So
And
technically, we call it as a pool data set. And that's your pure panel data. And many times you will find that the people are using them interchangeably, but technically we do make a difference.
And sir, if I have 10 variables for the 10 years, then it will be?
Same panel data.
Yeah.
Same cross-sectional units.
Yes.
Dr. Solanki, you should have the same cross-sectional units.
Yeah, definitely. I got it. Sir.
So many times the term panel data set and the pool data sets are used interchangeably, but we do make a difference. In panel data, the individuals, they form the countries, which are your cross-sectional units, for which data is being collected across the are same. While in pooled, they may be different. The terms panel data set or longitudinal data set, they are used interchangeably.
So may I just ask a question?
Yes, please.
Right, on the previous slide, right? So, sir, we were just talking about a panel data set and a pool data set, right? And you've just given example of the companies, right? 500 companies, and we say that this is an example of a panel data set. Let's take an example of Nifty 50 group, which changes frequently, right? So we have 50 companies in each year for the 10 years, but the composition of the Nifty 50, that is, those companies are changing each year. So
Right.
we will term it as a pool data set or a panel data set?
Pool data set.
Okay, sir. And the treatment would be different then.
Gaurav, do you think that will make a difference?
Sir, I'm not very good in econometrics. To be honest, sir, I don't know the answer.
गौरव ऐसे मत बोला करो.
अभी सर पढ़ रहा हूँ मैं थोड़ा.
Okay, no problem. That's not an issue. See, what we believe that if a company is out from an index, similar company is entering into the index. So for me, it's same Nifty, right? I don't look at differently because I know that if one company is out, similar nature of the company will be replaced by it. So we believe that all companies in Nifty, all 50 companies in Nifty are of similar nature, similar characteristics in terms of market capitalization, in terms of the size, in terms of the trading, liquidity, all those things we believe that they are by and large similar. Is that okay, Gaurav?
Okay, okay.
And that's why, Gaurav, you must have seen, people don't adjust Nifty return with the addition of new companies or deletion of old companies, because they believe that Nifty is same what it was before the addition and what it was after the addition. So let's work out the whole series and calculate the return that is not required to be adjusted. Why panel data analysis? Why should we go for panel data structure? What is the advantage we get out of it? Anyone? Why panel data analysis? Why should we do that?
To improve degrees of freedom.
Yes, that's one, because that will increase your sample size. Yes, Mr. Dutt, that's right. Anything else? It helps in controlling invisible, unobserved heterogeneity. What is it? We will discuss in detail a little later. Okay, more information, you have more data, more variability, less collinearity among variables, more degrees of freedom, hence more efficient estimates. This is one of the important benefit of panel data. By studying the repeated cross-section of the observations, panel data analysis is better suited to study the dynamics of the change. Panel data analysis can better detect and measure effect that simply cannot be observed in pure cross-sectional or pure time series data. Construct and test more complicated behavioral models than purely cross-sectional or time series data. Larger data sets, larger degrees of freedom. So I will put advantages broadly in two categories. One, larger data set, larger degrees of freedom, efficient estimates. And second, help us in capturing complexities of the module and of the behavior of the variables that you can do. To be precise, with repeated observations of enough cross-sectional panel analysis permits us to study dynamics of change with short time series. Combination of time series with cross-section can enhance quality and quantity of the data in ways that would be impossible if you have only one cross-section or time series. Rich and powerful study of set of people. If one is willing to consider both space and time dimension of the data. Why is there a need to talk about different tools of panel data analysis? Because I cannot use OLS. And since I'm not in a position to use OLS, I need to think something different. And we can have broadly two kinds of panel models, static and dynamic. And you know what is the difference you find here?
Time lag.
Same, but this makes dynamic model. So if we have lag of dependent variable in the model, my model becomes dynamic model. So the presence of this makes my model dynamic. So lags of dependent variable makes my model dynamic. And if you don't use it in your model, then it will be a static model. Today, we are not going to talk about dynamic models. We will be restricting ourselves to static models. So the models which we are going to discuss today will not have lags of dependent variable on the right-hand side of the equation.
So may I ask a question?
गौरव पूछने की जरूरत नहीं है, तुम पूछ लिया करो.
Sir, right. So, sir, it's sir, dynamic. Why this word dynamic? I mean, that's fine. You know, I understand that it has a lag of a dependent variable. But what is the meaning of this word dynamic? In what makes
Dynamic
it?
means that is something changing with the time, right?
Oh, okay.
So this is causing a change. So today decides what is going to happen tomorrow. So that means there is a connection of the change. Okay. So for example, if a company is having say more dividend today, what do you think in 2021? What do you think? What is the likelihood?
Maybe
May
some.
also give the higher dividend the next year. Okay, so your dividend this year depends upon what you had in the previous year. So there is a dynamic relation, the relation over time. That's why we call it dynamic.
Sir, this is the only way to get to know whether if suppose we are preparing the model, so it will be static or dynamic.
You have to take a call.
Pardon, sir?
You have to take a decision.
Okay. Yeah.
Dr. Solanki, what is your background? I will.
Sir, from finance.
Huh?
Finance.
Okay. If a company is having debt equity ratio of say 0.8 this year, what do you think? Next year क्या होगा? What will be the debt equity ratio next year?
If the company is
Will it dependent on the previous year or not?
it will be related.
It will be related, na? That
Yeah.
means the theory is telling you today's today's debt equity ratio is going to have an impact for the tomorrow's debt equity ratio.
Yes.
So there you have to use a dynamic pattern.
Good.
Okay. Right. Cash holding. Do you think cash holding of firm depends upon the previous year cash holding? If a company is having more cash with itself today, do you think next year will it have more or less? Will it have impact or not? Sign is different question. Will it have impact or not?
Sir, it will have.
Okay. Now I ask a question. If a company is declaring special dividend this year, do you think it will have impact on the next year dividend? Other
Not as
people
such
can
because
also
it depends.
answer it.
Not as such because it depends on the performance of the next year.
No. Special, Weber, you're right. It's a
Okay.
special dividend
Yes. Okay.
because of, say, silver jubilee or golden jubilee or something else. The company is declaring dividend. So that dividend is not going to impact you next year dividend. So no relation.
Yeah.
So theory will tell you whether they are statically connected or dynamically connected. And accordingly, you have to make a model.
Yes. Thank you.
But as I said, we shall concentrate on static models. So we have pooled regression. So all those assumptions have to be checked. Fixed effect model and random effect model. So these are the models which we are going to discuss. And we have to set up a parallel data structure in Stata. How do we do it? What is this represents? Cross and T for time. Stata understand panel as XT. X for cross section, T for time. So all commands in Stata you'll find starting with XT. Like XT set, XT rec, XT describe, XT summary, XT tabulation. This is the first step one has to do while performing panel data analysis in Stata to set your data structure. So XT set, then we write cross-sectional ID, and then time ID. And if you find that the cross-sectional units are in, string, but many times you have the cross-sectional units like name of the companies, which are string data. So in that case, you have to convert them into, numeric data. And for that, you can use this command. So let's go to Stata and see how we can do it. So I open up a file. I have data in Excel, so I import it. Suppose I take say birth data. Import first as a variable name, and you can see the data. That the data we have. So the data is related to the number of districts in years, birth rate, death rate, and number of Anganwadi workers. So it's a clear-cut panel data structure. So the very first thing which you have to do is you have to set the panel data structure. So the command here is xt set, then District is my cross-sectional ID here. So we have a strongly balanced panel, and that's the data which we have. And if you want a summary of it, you can get the summary. XT sum, and that's the summary of the variables. So capital N represent the total observations, and N is the observations of each cross-sectional unit, and T is the time. That's what we get. Okay, and more of it we will discuss as we proceed further, but that's how you can set the structure of panel in your Stata. Any question here? Like,
Sir, sorry to interrupt you.
hello?
Sir, I wanted to ask a question. Sir, we had a
Yes.
break scheduled from 11 a.m. to 11:30 a.m. So, sir, shall we take the break or can we continue?
Chaitanya, why do you worry about it? Don't
No,
worry.
wanted your opinion that shall we take it or can we continue?
No, I will tell you when we are going to have a
Sure,
break.
sir. Sure, sir.
Okay, what is this between and within? Here also you will see we have between and within. Overall is total, that's true. Anybody, any guess, what is this between and within?
Within the elements of a particular group, and if between the two groups.
Within is within the cross-sectional units, and between is between cross-sections. Yes, then you're right. Say if I have 5, this is cross-sectional 1, 5-year data, say 15, 16, 17, 18, 19. So if I calculate x1 minus x1, 1, mean of x1, that's within cross section. And when I talk about between, that means I take mean of it, mean of second, and then calculate variation among them. So then you're right, between within the between the cross-sectional units, and within means within each cross-sectional unit. So for calculating the between effect, it considers means of each individual over time, and then it decomposes xit into xi into between xi. And for calculating within, we use this. Mean of xi from each this. They say I hear, I forget, I see, I remember, I do, I understand. So we have already seen how do we get this between and within estimates. Any question before we go ahead? Anybody, any doubt, any query? No? Let's see what next we are going to talk about. They say difficult problem in life always start off being simple. And can you imagine what is the complexity of this model? Let's say panel data model. What's complex? Parameter attribute mean. I really don't know what you mean by parameter attribute mean. Too many variables. But there are too many variables is not a problem. I can take 2, 3, 4, 5. That's my choice. That's not an issue. But then too many variables is not a problem.
Sir, error term include both the components.
Which component? There is only one error.
No, time component and the cross-section component.
Because we have the panel data, no? So the error term will be for cross-section over each year. So because it's the error term of the panel data, so that's not a problem. Problem is here. Here is the problem. These are my problems. Shankar, independent variable is not a problem. Independent variable never creates problem. Do you see this? IT. Yes, Dhyan. Too many parameters to be estimated. What is the consequence of it? What will be the consequence of it? If you estimate large number of parameters, what will be the challenge? We lose degrees of freedom. And the more you lose degrees of freedom, then you're right. The more you lose your degrees of freedom, the quality of the estimates suffer. So very large number of parameters to be estimated. Consequently, we have to pay a very heavy price in terms of loss of degrees of freedom. Please understand that. Just a minute. लेकिन बाद में बात करता हूँ, बाद में बात करूँ. Now the question is what to do. When I see a lot of parameters are to be estimated and I'm losing my degrees of freedom, what should I do? Any solution? What is the solution? Anyone? We know the problem, but what is the solution of that problem? What is that we do in order to make complex thing simple? Chaitanya, I ask you a question. Chaitanya, tell me, if you're making a model, how to make a complex model to a simple model? How do you convert a complex model to a simple model?
So we try to reduce the number of
Assumptions. Absolutely right.
We can also try to reduce the number of variables.
But why you can do it? You have to make assumptions, reasons for the reduction. You can't do it arbitrarily.
Yes.
Assumptions plays a very, very important role. So what are the assumptions which we can make? That is something which we have to think. The solution is make necessary assumptions. So what is the assumption which you can make? It is easy to make assumptions, but remember that it should not destroy the underlying reality which we are searching for. So one of the assumptions which we can make is relating it here. So one assumption is that I can assume that all parameters are constant. They're not changing with cross-sectional unit and the time. In this model, we are assuming everything is constant. No effect of time, no effect of cross-sectional. In that case, you can make use of OLS. Okay, so you have panel structure, XIT, YIT. We make assumption. And the assumption is no time effect and no cross-sectional effect. You know what is the implication of it? Every year is identical. So year-wise, we don't see any kind of difference. Every cross-sectional is homogeneous. So we don't see any difference in cross-section. So company A, B, C, D, all are identical in their behavior, in their structure. Yes, Dr. Priyanka, do you like to say something? And when you assume that no time effect, no cross-sectional effect, then you are simply reducing to regression. What? And in fact, before panel techniques started coming into picture, before that, people used to pull them and use OLS. Because they were making an assumption that cross-sectional, there is no impact, and over the time also there is no impact. Okay. So can I use OLS for the panel data? The answer is yes, under the strong assumption that no time effect, no panel effect. And let's show you how to be good. Just a minute. आशीष भी कॉल करता हूँ. So here you simply regress. And with death rate as a dependent variable, birth rate is this, and number of workers this. And that is simple OLS which we get. So none of them is coming to be significant at 5% level. Okay, so many people believe that you cannot use OLS in the panel data. You can do that, but you have to make very, very strong assumptions. Dr. Priyanka, can you mute yourself? Chaitanya.
Yes, sir. Kaushlin sir, please mute Dr. Priyanka.
Priyanka को mute करो.
Kaushlin sir, please mute Dr. Priyanka.
ठीक है सर.
Kaushlin sir, can you hear me? Sir, she's muted.
Okay. So if make assumption that all cross-sectional units are having same behavior, no time difference, then you pool the data and use OLS. But if you don't make these assumptions, what to do? That's again a challenge for us. Because we believe that these assumptions are not realistic and we may not be able to get the results. And that's what we discuss in that example which we have taken. So pulling data and using it, and that's the result which we get. Okay. Do you think that the assumption of the pool data analysis are satisfied here? Do you see district-wise differences? Time-wise differences? So we observe that district-wise there are differences and time-wise there are differences. So these assumptions which we have made so far will not be valid assumptions. What to do? What should we do? Is there any efficient way to take care of this problem? We have a district effect, we have the time effect. From district to district, the behavior is different. From industry to industry, the behavior is different. And also over time, the behavior is different. What to do in such a case? Think. What we can do in such a case. How do we do this? That we will discuss next. And before that, let's have a break. And after the break, we will come back. But before that, any question, any query which we have. We appreciate the problem arising because of omitted variables. We understand certain basics of panel data. And we also talked about pooled regression. And we are going to discuss the challenges. What if cross-sectional effect is different, time effect is different. Okay, so that will be our challenges that we are going to meet before after the break. Endogeneity problem, fixed effect module, random effect module. That's the next thing which we are going to discuss and talk about. So let's have a break. Chaitanya, after what time we should come back?
Sir, you can suggest the time.
15 minutes break.
Okay, sir.
11:35. Will that be okay?
Yes, sir. Okay.
Or
So
11:40?
participants, we are taking. Sir, if 11:45 35 suits you, we'll come back at 11:35.
11:35.
Yes, sir. 11:35.
Okay, great.
Participants, we are taking a short 15 minutes break. I request you to kindly join back by 11:35 a.m. We will start at 11:35. Thank you. Thank you, sir.
Thank you. So friends, let's start and welcome back and start with this statement: we rise by supporting each other. And in research, everyone cooperation is highly appreciated, and you need cooperation, and you need support of each other, and that's very, very important. So you rise because you support each other. None will believe you if you cannot prove it. We need proof. That is important. In research, we accept proof, nothing but proof. If you say that I am having so many years of experience, I know this, and that's why it is correct, no, we don't accept it. That's not scientific way of doing research. You have to prove, and whatever you want to say, you have to prove it. Only then we will accept it. If you don't prove it, we will not accept it. They say only in God we trust, and others have to prove. So exception is God, but all others have to prove. So let's see what next we are going to talk about. If you recall that we talk about consequences of omitted variable bias, and we say that never lose sight of the underlying theory. And omitted variable creates problem, and our estimates become biased estimates. Okay. Before I go ahead, any quick questions if you have and might come into your mind during the break? Any question, any doubt, any query, please make sure that you are understanding what we're talking about. Sudeshna, Dr. Salanki, Dr. Nayak, Padyan, Gaurav, anyone, any questions? Imran? No? Okay. So we said we will talk about problem of endogeneity. Endogeneity broadly refers to situations in which an explanatory variable is correlated with error. So X is correlated with error. By endogeneity, we mean the correlation of the right-hand side regressors with the error terms of the disturbances. That is, covariance between X and error term is not equal to 0, then we have a problem of endogeneity. On the other hand, exogeneity means that each variable X does not depend upon dependent variable Y, rather than Y depends on X and the error. Now, what does it mean? It means the following. Y is a function of X error. Okay, so error term determines Y. Okay, if error term is impacting X, then impacting Y, you know what is the problem? You will see. I think let me put it the other way around. Error term is impacting my Y. Okay, anyone from economics? Anyone from economics? चैतन्य इकोनॉमिक्स से है कोई बंदा?
Sir, I do know. Any participants who belong to economics background, please respond to sir.
Okay.
Sir, I am from agricultural economics, not your economics.
Okay. Okay. So, Dr. Singh, tell me, what is an exogenous variable?
Pardon?
Exogenous variable.
In plain terms, these are independent variables.
Right. What does it mean? And what is endogenous?
Endogenous are dependent variables in layman terms.
Yes. But we say that endogenous is something which is determined within the model, right? And exogenous is something which is determined outside the model. So you have Y, you have X. So X is determined outside. model, and X is determining Y, that's within the model. That's the typical meaning of exogenous and endogenous. The same meaning we use here when we define endogeneity problem or exogeneity. So if the error term is determining Y, right, and Y is determining X, why Y is determining X? Because error term is also correlated with X. Then both are determined within the system. Y is determined within the system and also X is determined within the system. So there we find the endogeneity problem, because error term is determining Y as well as X, because they are correlated. And due to that, we have exogeneity issue or endogeneity issue. Y depends on X as well as on error. Exogeneity means X variable does not depend upon the dependent variable Y. So error term determine Y, Y does not determine X. Therefore, error term is not correlated with X. Then we have exogeneity. Since Y depends on error term, this means that X's are assumed to be independent of Y, hence independent of error terms. It is required because if the independent variables are not dependent of error term and Y, then our regression coefficients may not be unbiased, consistent, efficient if we use OLS. So what does it mean? Exogeneity ensures blue properties of OLS, and endogeneity does not ensure blue property of OLS. And then we define strict exogeneity and weak exogeneity. We have mathematical definition of it that you can study, but what does it mean? I explained you. If all terms present, past, future, if all these terms are not correlated with error, then we have a strict exogeneity. You take past figure, present figure, future figure, nowhere you come across with covariance of X and the error term. All the time you get this. Then we say we have strict exogeneity. Neither past impacts nor present nor future. And this is what it means. T minus S, okay, and T plus S. That's past and that's future. So the strict exogeneity means the error term is unrelated with the past, present, future values of X. In such a case, X is completely independent of Y. On the other hand, weak, look at this, past, 0, but future, may not be zero. In that case, we see we have a weak exogeneity. So in weak exogeneity, error term is unrelated, not correlated with the past, but it may be correlated with future. Is that meaning clear?
Yes, sir.
And what we need for our econometric modeling is strict exogeneity, not weak exogeneity. Exogeneity ensures that OLS estimates are blue, while endogeneity creates problem for OLS estimates as they are no longer blue estimates. Exogeneity is our friend, endogeneity is a foe. And the strict exogeneity is required to obtain unbiased OLS estimators. Important. Okay. Why we have endogeneity? Endogeneity may be because of omitted variable bias, maybe because of the measurement error, simultaneity, and dynamic relationship. This could be the possible reasons for endogeneity problem. Okay, so we have understood endogeneity problem meaning and why it happens. Can we statistically prove that we have endogeneity problem? Anyone? Udyan, please tell me. Postman test. Okay. Then which Postman test you're talking about? Is it possible for us to check endogeneity problem? Yes, so then that's for fixed effect and random effect, but not for endogeneity issue. Anyone? No, statistically we cannot prove whether endogeneity problem exists or not exists. Who will tell me the underlying? It is the underlying theory that will tell you whether you have endogeneity problem or you don't have endogeneity problem. As such, we do not have any theoretical or analytical or statistical model to prove that the model is suffering from endogeneity problem. Arti is saying autocorrelation. Arti, autocorrelation means error terms are not correlated. Ith error term and the jth error term. The covariance between them is 0. That's autocorrelation. We are not talking about autocorrelation. We are talking about covariance between X and the error term. So autocorrelation is a different problem and endogeneity is a different problem. So friends, having discussed this, let's continue with our discussion on the panel data. And if you recall that if you have this module, you are having a lot of parameters to be estimated and we lose degrees of freedom. For that, we have to make necessary assumptions. And if we assume that cross-sectional units are not heterogeneous, all are identical, same, all time periods are same, then we can use pooled and use Euler's. Yes, Udyan, you're absolutely right. We do not know the error term. In fact, nobody knows the error term truly. So as a result, I cannot prove it. So now let's time to take challenges of the panel data and start our journey with the neuron. Let's devote some time in thinking. I took the data that giving me the relation between population and GDP of 5 different countries. So you have Austria, Belgium, and Finland, and Denmark, and that's France. And if I fit a straight line or the line of the best fit, what's wrong in it? You will not get the best estimates because every country is different. To make an assumption that they are identical, that's a very wrong assumption. Should you fit 5 different lines for each country? France separate, Belgium separate, Denmark separate, Finland separate. Should we do that? Dr. Naik, are you there?
Yes, sir.
Yes, should we apply different regression line to different country?
Yes, sir. If the data allows, we can proceed.
You know why I'm saying say no? Because if you bifurcate them, then you are reducing the sample size and you're not able to take the advantage of the panel data structure. So that I will not suggest. Okay, so we have to take a call, this or something else. Should I go for like something like this? I have a very fundamental question. Why different behavior of different countries? Why do we have different behavior of different countries?
Due to their geographical location and some other factors also, sir. It is not
Sorry?
that geographical.
All are European countries. So I don't think, and they have adjacent borders. So I don't think geographical location makes a lot of difference to them. But I think you were about to say some other factors. Level of development. Yes, Ravichandran.
Their development index, different development index.
What else? Culture. Education level. Degree of industrialization. I mean, so many factors might be there. Okay, it might be possible I'm not aware of all of them. But we do believe that, countries are different because of a number of factors. But I have only two pieces of information, the GDP and population. So if you make a model that GDP is alpha plus beta population plus error term, क्या होगा? Where the effect of all this will go? Where you will see the effect of all this?
In the error term?
They will go to
In
the
the
error
error
term.
term?
And if these factors are related with the population, then what will happen? What will happen? Just imagine.
There will be
क्या होगा?
endogeneity problem.
Yes, Rishna, right. It will create endogeneity problem. But these are all omitted variables in my model. And I have no information about it. I have no data about it. And all are sitting in my error term, creating endogeneity problem, how to take care of it. Please appreciate the problem. Okay. Another problem which I was talking about is your death rate. Is equal to alpha plus beta birth rate plus beta 2 number of Anganwadi workers plus error term. And data has been collected from different districts. Do you believe that all districts are same or are they different? Are they same or are they different?
Different.
They are different.
Right. Why they are different?
Because of the socioeconomic, differences.
Right.
There are some districts.
Level of poverty, level of education, health conditions, infrastructure, so many things.
Yes.
Okay. So these are all omitted, right? And where they will sit? They will sit in my
Error term.
And they may create problem of correlation with birth rate.
True.
And if they are correlated with the error term, my model is suffering from endogeneity problem. How to take care of it, that's the challenge. I hope you people have understood and appreciated the problem at which I'm hitting. Because unless and until you appreciate the problem, you can never appreciate its solution. So think what you want to do with the data and what is the data generating process at the back of it. And if we try to use here OLS, then it may give you biased estimates, inconsistent, inefficient estimates. So, and nobody wants it, so I cannot make use of OLS. And please note that exogeneity ensures OLS estimates to blue. And if you have endogeneity problems, then it will create problem for the OLS estimates. They will no longer be blue estimates. So let's come back to our main issue of the panel data and richness. We have to capture it. And what are the costs one has to pay for using panel data analysis? Anyone? One of the simplest way to take care of the panel data is make assumptions. And if you make assumptions, you can take care of it. If you strongly believe and theory suggests no heterogeneity among cross-sectional and no difference over time, pool the data, use OLS, ensure strict heterogeneity, everything will be taken care of. No worry in that particular case, but these assumptions are not realistic. What do we do? Okay, so that's what we have already discussed. No time effect, no cross-sectional effect, and use OLS and you get the result. But when we try to exploit the richness of the panel data, we find certain problems. Any problem you see here, if you use OLS, क्या होगा? Aarti, now you see what exactly may be the problem. Aarti, think of what you said. Same district, if you observe over a period of time, what will happen? Same district, district 1. Observe different points of time. How you will see data here? OLS estimates will no longer be blue as individual cross-sectional unit observed repeatedly over a period of time, and it might be possible that the error term of this period may be correlated with the error term of this period. You may have autocorrelation problem. How to take care of it? That's the issue which we have to look at. So we are facing, friends, two kinds of the problems. One, endogeneity problem due to the omitted variable bias, and correlated error terms problem due to the repeated observation of a cross-sectional unit. To begin with, I move with this problem. I repeat what I said. So we have a model y is equal to IT is equal to alpha plus beta xit plus error term IT. Okay, there are certain unobserved factors. Unobserved because I do not know, but I feel that these variables might be there, like you said. And these all unobserved factors are sitting into my error term. And they are also impacting my independent variable and thus causing an correlation between X and error term, and thereby causing a problem of endogeneity. And if you have endogeneity problem, you apply OLS, your results will not be blue results. question is what to do. Yes, so then, can you suggest what we can do here? And you know what is the assumption I'm making? I'm assuming that there are unobserved factors. We can remove unobserved heterogeneity. Then why do you say heterogeneity? You could have said unobserved factors. Why heterogeneity? Aarti Sharma, by using dummy variables. Okay, yes, Aarti, you are right. We can take care of this problem by using dummy variables. Anybody else? Friends, I'm not in a hurry, please, but make sure that you are understanding. The things are becoming slightly more technical now. So we have to meet these challenges, and we are not afraid of challenges. We love challenges. So we are looking at challenge number 1, endogeneity problem caused by, Aarti, what do you mean by fixed or random choice? If we have omitted variable in our model, okay, fixed effect model, random effect model. Okay, anyway, let's understand it. If we have omitted variables in our model, you know what is the best solution? The best solution is include them into your model. But if they are unobserved, we do not know about them, I cannot include them, and therefore we have to take care of them. So if you know them, you have the data with you, include it into your model. If you don't, then you have to take care of it. How to take care of it? That's challenge. So what kind of endogeneity problem we are going to address? The endogeneity problem, which is caused by unit specific unobserved heterogeneity. Okay? What does it mean? Cross-sectional units heterogeneous, and we have unobserved omitted variables, and above all we are assuming they are all time variant. Aarti, please understand it. The assumption which you are making and the kind of the endogeneity problem we are taking care of. Endogeneity problem, which is created by cross-sectional unobserved heterogeneity. And we are assuming that that heterogeneity is not changing with time, invariant with time. But then is that clear? So we are taking care of unobserved cross-sectional heterogeneity. And that takes us to fixed effect model, which is also called within estimator or fixed effect estimator, whatever name you call it. So first, I will take a problem with 2 time periods, before and after. So the typical example you will find in the literature about impact of peer text on fatality rate, and that is scatter plot. The red ones are 82 figures and the green ones are 88 figures. Look at this. I'm considering only 2 time period, before and after. It's 2, it's 3, for example. And look at this alpha I, which we have here. No T subscript. That means this is something which is changing with cross-sectional units. And this is what we say as unobserved cross-sectional heterogeneity. Yes, so then how to take care of this cross-sectional unit alpha I? How to take care of it? Then now you recall what you said earlier. Then we actually don't require mean here because we have only 2 time period. What we can do? Yes, take difference. So if you have, say, y1 I is equal to beta naught plus beta 1, okay, I put it like this. y1 I is equal to beta xit plus alpha 1 error term, y2i one t, 2t, when you take a difference, what happens? This cancelled out, goes out. And when it goes out, that endogeneity problem caused by it will not exist. And that's how you'll take care of it. Take a difference. And that's what we said, unobserved unit specific heterogeneity. And the solution is take the difference. So if you have heterogeneity of the factors impacting the dependent variable, which are not in our model, one is get them all if possible, but it is not possible, so we have to take care of them. And if we use OLS in such a case, we will face endogeneity problem, so we will not use OLS. So what we do, we go for first difference estimator. Take the difference. And when you take the difference, then that alpha I term goes out. And that's how we have taken care of it. Okay. So let's go to Stata, and to get the difference, you can use this command, regress, difference of fatality rate and p-index. Okay, so let me go to Stata and see how we can do that. So I open up a file. So if you want to see the structure of it, that's the data which we have. So we have the state, we have the year, BRTX, and fatality rate. So we have it 2 years. Okay, so what we have to do first, define the panel structure, xt set, state and year. Then suppose I run without caring. Sorry. Press fatality rate, BRTX. And see what is happening. Positive, significant. If I do like this, I get a conclusion that if states are increasing BRTX, fatality rate will go up because we have a positive relationship. But that's what we are not expecting. What to do in that case? Can you imagine why this result is coming in? Why this result is coming in? So if I take the first difference, I regress d dot fatality rate and BRTX. What we get here. And now, who will give me the interpretation of it? And you have two models before you, positive effect model, significant, and difference model, which is not significant. Sorry, difference model with negative relationship. Anyone?
Sir, can I try, sir?
सुदेशना ट्राई तो करते रहना चाहिए हमेशा.
Sir,
do that.
maybe in the first model, there were some unobserved factors that was causing the increase in fatality rate.
Right.
So, and
कौन
when
से
we,
unobserved factor होंगे?
sir, that is
State
that,
wise. State, because the cross-sectional unit is a state. So every state may be different in its culture and, consumption of the beer and, the income levels. So many things are there.
yes, sir.
Just a minute.
Yes, sir.
Hello. क्यों क्या हुआ? चंद्रा, अच्छा उसको क्या तो फोन कर लेगी वो. Just a minute. Yes, how we will do it? Take a minute and think over it, and what we get out of it, that is something which we have to understand. Okay, just give me a minute. I will come back and discuss with you. Yes, anyone? Think a researcher is having data about beer, takes, and can you imagine what will be the research issue before that researcher? And it's very common problem. It's not a theoretical, complicated, domain-specific problem, common sense problem. Can you imagine what should be the issues before the researcher when he has data about beer takes and fertility rate? What is that he would like to do with this data? Increase in beer takes have significant impact to reduce. Okay, I'm using two terms. higher vertex or increase in vertex. आरती क्या फर्क है दोनों में? If somebody says we have higher tax rates and somebody says increase in the tax rates, are these two identical or there is a difference?
Static dynamic.
Hello? Hello?
Sir, one is static and other is dynamic.
Okay, Solanki, in simple terms, what does it mean? When you say static, it's not referring to change.
Yeah, one is not changing and other is changing every for the time.
So as a researcher, what you would like to know? Change in the tax rate, impact on it, or the level which is impacting it? What is important for a policymaker? High rates or the change?
Change.
The impact of change.
Change. So the moment you say change, that means you are talking about difference. And that's the reason, this module is a better module. Two reasons. One, it is of interest to me because I'm looking for the impact of the change of the text. And second is that unobserved heterogeneity have been taken care of. So I should go for this module, better module. Then I don't know what you mean by logit is more relevant. I don't know what you mean by logistic regression. Logistic regression is altogether different. Okay, so when you take the logistic regression, you will get only plus minus. That's it. But you will not be able to quantify the magnitude of the change. So I will not suggest that you should go for logistic regression. You go for difference regression. So researchers should always be in a thinking mode. Always. And look at the following graph and crime and unemployment rate. And research issues may be what is the relation between crimes and unemployment rate, relation between crimes and unemployment rate, controlling the effect of the time, relation between crime and the unemployment rate, controlling the effect of the states, relation between the change in the crime and the change in the unemployment rate, and what is the percentage change in crime due to the percentage change in unemployment. All those things you have to take care of. Now, what is the relevant research issue for you? You have to make model accordingly. Okay, so I think let me take you back to that file import. crime period. And that's the data which we have. So we have the crimes, we have the unemployment rate, we have the year, and we have the states. So we have to define panel structure, XT set. We have the states and the year. And if I just run regress the crime and the unemployment rate, it is not coming to be significant. Okay, but if I regress with a difference, D dot, if I take their difference, see what happens. This is coming to be significant. R square is also improved. That shows how you will interpret this result. If unemployment rate increases, then rate of crime or the change in the crimes will, because we have a negative relationship. So we have to be careful what is my problem, and accordingly you have to do the analysis of the same. Any question here? Anybody? Any doubt? That we have done. Any question? So, yes.
Sir, like if I have to, can I
Bolo,
say that
bolo.
first?
Yes, Deshna, please.
Yeah, sir, if I have to conclude, so first time when I regressed rate of crime and unemployment, I was trying to find out the relationship between rate of crime and unemployment. And second
Level.
time when I,
Level.
time,
At
yes,
level.
at level. So second time when I took the first difference, so that time I mean that I'm measuring the impact of change in the
Change.
level of
Yes.
unemployment to the rate of
Right.
crime.
Right.
Is it okay, sir?
Yes. Absolutely right. So as a researcher, what is important for you? You have to take a call. Level or the change. So that is something which you have to look at. So 2 period, maybe before or after unobserved heterogeneity. So this is the kind of the situation we have come across for the time being. Then if we have more than 2 period, then what should we do? Look at this. And your time period may be up to 15. And this kind of a model is called fixed effect model, because this effect is fixed over time. What does it represent? Unit specific time invariant time invariant heterogeneity. Okay, so for that case, we use what is called a fixed effect model. Aarti, to take care of it, we have two options. Use dummy, as you said.
Sir.
And another is, as Udyan is saying, take difference. So what difference we have to take, we will discuss it. But you can make use of dummy variable. No problem with it. Because you have to take care of it. And one of the way to take care of it, introduce dummy variable for each cross-sectional unit. So please note that whatever effects the omitted variables have on individual unit at one time, they will also have the same effect at a later time. Hence, the effect is constant, fixed over time. Time invariant. So fixed effect estimator allows correlation between omitted variable or time invariant variables with the observable explanatory variables. That means that unobserved, cross-sectional heterogeneity, which is sitting into my module. I'm not writing subscript that you can understand. Sitting in the error term may be correlated with X. That's what we are saying. Omitted variables or time invariant variables, that's what we say. And of course, we are assuming strict exogeneity. That means the error term is not correlated with your XIT and alpha. One method is LSTV, as Aarti is suggesting, but it creates a problem when you have very large number. So Aarti, imagine if you're working with 1,000 companies, it's not possible for you to introduce almost 1,000 dummy variables. If you do it, very huge problem you will come across. So that we can avoid, and for that we go for what is called fixed effect estimator or within estimator. चैतन्य याद करो within क्या चीज बताई थी मैंने?
So within was correlation among the items within a unit, within a group.
Correlation की तो चैतन्य मैंने बात ही नहीं करी थी within में.
Fixed effect, sir.
Within में तो बात ही नहीं हुई थी. Within में difference.
Yes, sir, sorry.
Difference from what?
Mean.
Mean of that cross-sectional unit. So LSTV method, we can make use of it. You can introduce dummy, but it will not work, or it will create problem when n is very, very large. So in that case, what we do, we go for fixed effect estimator, and we have to remove alpha I, take difference, and that difference we take when we, go for when we demean it, or we subtract mean of each cross-sectional unit from each observation of cross-sectional unit. And that effect is called fixed effect estimator or within estimator. Now see here, mean of ith observation. This is of ith observation. And since they are equal, that will be cancelled out. So we are happy with that. As Udyan sometime back said, we have to demean it. That means subtract mean from each observation of that particular cross-sectional unit. If we do it, then we get what is called a within estimator or fixed effect estimator. These estimators are consistent, and if they are strictly exogenous, they will also ensure that they are unbiased estimator. Okay, so fixed effect model controls for all time invariant differences between the individuals, so that the estimated coefficients of the fixed effect models cannot be biased because of omitted time invariant characteristic. So let's go to Stata and practice it. Any question if you have here? This I can close. Okay, so I take the same problem. So xt set and district here, then xtreg. We have a rate, that rate, number of, and then simple, you have to write FE to show that it's fixed effect model. And that's the result which we get. And no variable is coming to be significant here. If I use a dummy variable, and you will see you will get the same results. Regress. So we have birth rate, death rate, number of workers. And to introduce dummy, we write I dot district. For every cross-sectional, I'm using dummy variable. So yes, if you see here, the impact of the using dummy or using fixed effect estimator, results will be same, no difference. But as I said, if you have very large cross-sectional units, 1,000, 2,000, then it will be difficult for me to handle all the dummy variables. Then you should go for FE test. Okay, so now let's try to understand what this output represents. So we have R square within mean. Which one I should take? Anyone? Which R is square? Which R is square I should take? Anybody guess? Fixed effect estimator is Shankar. Yes, Shankar say. Right, within. Because it is within estimator. So we have to take
Within.
Okay. Then we have overall correlation. That's how we calculate it. But here we have to work with within R square. This is your usual F. What F statistics tell me in regression? It's a result of the Wald test, which with the null hypothesis that dependent variables have no impact. Rejected, that means independent variables are having impact on your dependent variables. And there is no cross-sectional unit differences. UI in the Stata means cross-sectional observations. So it says no effect whatsoever you have. And this is the correlation between unobserved and your X. So correlation is minus 0.3812. Why I'm talking about it, maybe we appreciate it when we discuss random effect. And it tests whether the individual effect because of the omitted variable is significantly different from 0 or not. And if you're running a cross-sectional model with the dummy, then you can use this test param I dot cross-section ID. Show you what I mean by this. If I use here test I dot district, and see the value is 1.42, 1.42. If value is probability is 0.2598, 0.2598. So even if you are using the LSDV method, the least square dummy variable method, you can find out whether the cross-sectional units are heterogeneous or they are not heterogeneous. Okay, so I think let me take one more example to give you the feel about fixed effect. Right, I showed the data about the leverage. Leverage is measured in terms of debt equity ratio. profit margin, and liquidity. So I'm saying that leverage depends upon profit margin of the company and the liquidity of the company, which is measured in terms of current ratio. Okay. So the very first thing which we have to do is XT set the company's ID and year, and then we run xtreg. Dummy is independent is my leverage, comma FE, and that's the result which we get. So that shows up profit margin and liquidity has impact on my debt equity ratio or leverage, and it's a positive impact. And within R square is high, F is coming to be significant, and there exists heterogeneity among companies. Correlation is also very high. Anything anyone would like to understand about this output? Any question about this output? Anyone having any question about output? No? Okay. So friends, trust that you started understanding fixed effect model. And as I said, no difference between LSTV estimators and fixed effect estimators. We have done the practice, I've shown you, and this you can use for checking cross-sectional heterogeneity. And you can also have two-way effect. You can add a time dummy as well into your model. Say if I run it, then I can also add here time dummy by using I dot year. FE, and you can see the impact of the time. So there are some huge changes in certain years that you can understand, you can explain why those changes are happening in those particular period of time. So let me summarize where we can make use of, fixed effect. I can use fixed effect in the panel structure where I'm assuming that we have cross-sectional time invariant heterogeneity, which is omitted. And we have two methods for it within estimator or fixed effect estimator and LSTV, the least square dummy variable method. Both methods give you the same result. Okay, you can also add dummy of time to capture time effect separately. So these are the things which you can do in it. Unobserved cross-sectional variant and time invariant, unobserved cross-sectional invariant and time variant using dummy variant. And the limitation of the fixed effect is if you have something which is time invariant, that you cannot use in fixed effect. So that's the problem with it. This I've seen. Let me summarize. So, effect of unobserved omitted variable. Time invariant, fixed effect, it's good. But if you have observable time invariant variables like industry, for example, a company belongs to a particular industry and that is not changing with the time, then effect of industry you cannot capture if you use fixed effect model. And in that sense, I say it's bad, not good. So we know where I can apply. I also know what I cannot do with fixed effect model. Next thing which we are going to talk about is random effect. But before that, if you have any questions, let me know. We assume about it fixed over time. And XIT and this unobserved AB correlated may not have zero covariance. So let's change our assumptions and then see what happens. Okay, so now I assume that this alpha I is not correlated with X. The correlation between X and this alpha I is 0. And it is not fixed over time. It changes with time. And random in nature. And that's the reason we call this kind of a model as a random effect model. Unobserved heterogeneity is behaving in a random fashion, not fixed. And not correlated with regression. That's another important assumption you have to understand. Then I can work with random effect model. In a random effect model, the unobserved variables are assumed to be uncorrelated with all the observed variables. We'll estimate the effects of the time invariant variables. We'll estimate the effects of time invariant variables. And the estimates may be biased because we are not controlling for omitted variables if they are found to be correlated with explanatory variables. The random effect assumption include all fixed effect model assumptions that again with the assumption that alpha i's are independent of xi's. Okay, so चैतन्य बताओ क्या फर्क है assumptions में दोनों की? Correlation, covariance between x and your alpha I, which is unobserved. Omitted variables may not be equal to 0, but in case of random, covariance between x and alpha I should be 0. That's very important assumption which we allow to be there in random effect and in fixed effect. Another, whatever we have unobserved heterogeneity, that is time invariant, and here time variant, and have random behavior. I really don't know कि तुम लोगों को ये समझ में आया कि नहीं आया है क्या नहीं है, but I must know whether you people are understanding it. कोई confusion, कोई doubt कुछ हो तो please don't hesitate. Anyone, any question?
Sir,
Yes, Sudan, thank you. It's clear to you, that's good. Yes, yes, Sudeshna.
Sir, ये random effect का first assumption, the covariance between x and alpha I is equal to 0. If I am assuming that,
assumption है. ये बहुत important assumption है.
yeah, sir, if I am assuming that there is no correlation between x and alpha I, so is it right to assume, means will the result will not be biased?
Assumption सही है कि नहीं है? That you have to check. Hello? हाँ. कौन सी कंपनी से? मेरी बात कर रहा हूँ उनसे. सुदेशना, तुम्हें डिसाइड करना पड़ेगा कि ये तुम्हारी प्रॉब्लम के लिए assumption सही है कि नहीं.
Okay, sir.
और कोई आपको बताएगा नहीं इसके बारे में. तुम चेक भी नहीं कर सकते क्योंकि अल्फा तो तुम्हें मालूम ही नहीं है.
Yes, sir. So that is what I'm worried ki results like could be misleading. So
Anybody else? And when you have it, you know what you will observe. Sorry. Hello? 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 Who's? So this is random. This is random. This will sit into it. And that's what will happen. And we have to be careful about it. So if I define a composite error term, UIT, which is equal to these two, then we can observe certain characteristics. Mean of the error term is 0. Homoscedasticity problem is here. Errors of the individual I are correlated over period of time. And this create autocorrelation problem. And if you remember, this is the problem I raised when I discussed this particular slide. If you remember, I said that, error term may be correlated if you take same cross-sectional unit over a period of time. And that's what is being observed in case of, autocorrelation problem. Correlated error terms due to repeated observations of the cross-sectional unit. This problem can be taken care of by your random effect model. Right? Then if your model is suffering from autocorrelation, can you use OLS? What can you use to take care of autocorrelation problem? Anyone? How to take care of autocorrelation problem? Everything else you will find, it's not a problem. Problem is here.
By differencing the variable?
No. That's not a solution. The moment you take a differencing of variables, then you lose information. I don't want to lose any information. No, then no. GLS, if you remember, OLS doesn't work. GLS work, the generalized least square method. And that's what we use for random effect model. Autocorrelation problem. And this is being taken care of by GLS. Generalized least square method. So fixed effect, OLS or within estimator, random effect, visible generalized least square method. These are the estimators we use. GLS estimator has desirable properties with large N, small t. And we lose the exact results of blue estimates, but they are consistent, efficient, normally distributed for large sample. Okay, so normally in panel data, you have large sample, so you need not to worry about it. So let's see, how do we do the random effect in the Stata? Very simple. You go back to your commands. Instead of RE, you write FE. Instead of FE, you write RE, and you get the random effect model. And that's the result which we get. Again, I'm getting the significant results. Fixed effect was also giving me the significant results. value of the coefficients are different. And if I take another file, suppose I take the quantity of tea and price with the panel structure. And if you see the data, this is the data we have. The quantity of tea, price of coffee, price of tea in different market in different years. And I can set xt set the markets and the year, and then xtreg demand for tea is a function of price of the coffee, price of the tea, RE, and that's the result which we get. And I think in fix and that's the result which we get. Okay. Then we often confront with the choice between fixed effect and random. For that, we use what is called a Postman test. This is the test that helps us in deciding whether we should go for fixed effect or random effect. The null hypothesis of the test is that random effect and the fixed effect estimates are systematically equal. And it follows the chi-square distribution. And the underlying idea behind Postman test is that the coefficient estimates from random effect and the estimates from fixed effect estimates are systematically equal. If there is no correlation between alpha I and explanatory variables, I should go for random effect. If they are having correlation, then we should go for fixed effect. Okay, so let's see how can we do it. So I run the regression. Let me first run the fixed effect model. And save the estimates. Do you see this number? Correlation is not very high, so it gives an idea that we may get random effect as the appropriate model. So you store estimate, fix, then you run the random effect model, then store it as rand. Any name you can give, store the results of the random effect, and then you say Hosmin fix, then that's what we get. And if you see the null hypothesis that they are not different, that is not rejected. And if it is not rejected, then we should go for random effect. If it is rejected, then we go for fixed effect. If it is not rejected, then we do not go for fixed effect. If I take another module, say the leverage data module. So first define the structure XT set, company ID and the year. Then define fixed effect XT reg, leverage, fixed effect. Then store it in fix. Then run RE effect model. Then store in random. Then run the Hosmin. Rejected. Then we should go for fixed effect. And it makes a sense because if I show you the correlation that exists between the unobserved, sorry, if you see the correlation between unobserved and XI, it's very high. So if you get the correlation, then most likely you are going to have the fixed effect model. So in this case, we must use fixed effect model. That the conclusion which we get when we are looking at this particular number. Okay. So that we have done. So do you think that we have understood fixed effect model and random effect model? Any question about it? And it's very simple to do it in the Stata. You will not find difficulty in the Stata. Okay, row. A row is the fraction of the variances due to UI. So let me take here. So variance of it, this is the standard deviation plus variance of it. Let's call it variance of U variance of error. Then rho is variance of the unobserved divided by variance of mu plus. That's how we calculated this. So how much variance is due to the unobserved out of the total? That's the interpretation of the rho. Variance due to unobserved out of total. So anything else? Any other question? Yes, preferably it should be as low as possible so that you are not having much impact from unobserved. So friends, that's all from my side today. Nothing more to be discussed. If you have any issue, any questions, again, I say you're most welcome. Sudeshna Nayak, Chaitanya. No? So thank you very much for being with me. Thanks a lot. Thanks.
Thank you, sir.
Thank you.
Wonderful session, sir. We enjoyed. They can again one
Thank
more
you.
session at 2:00. So,
Thank you, Dr. Nayak. Thank you.
yeah, sir, please leave your address so that a contact number will be in touch with you. To the coordinator, Professor Das.
Yes, we will share sir's contact ID in the WhatsApp.
Okay. So that we can contact Professor Gupta later whenever we need to have a Delhi so that we can contact him.
That's my email address.
Okay.
Thank you, Professor, for such a
Thank you, Sudeshna. Thank you.
Das sir, should we end the session here and join back at 2 p.m.? Okay, I request all the participants to kindly join back at 2 p.m. For the next session, which will be taken by Dr. Das. So you can take a half-an-hour break. Thank you, Professor, once again for the session.
Thank you. Thank you. Thanks. So should I leave the meeting?
Yes, sir, you may
Chaitanya?
leave. Yes, sir, you may
Ma'am,
leave the
can you
meeting now.
share the attendance link?
Yeah, we will share it again. Thank you, sir. We are sharing.
So then I'll announce the details.
Kaushleen, sir, can you please share the attendance link again?
I'm sharing it.
Das sir, should we join back at 2 p.m.?
Yes. 2 to 3:30 there will be class, and 3:30 to 4 o'clock there will be an exam. So at 4 o'clock we'll wind up the program. Okay.
Okay, sir.
So kindly announce that the classes from 2 to 3:30.
Participants, the next class is from 2 p.m. to 3:30 p.m. and after that we will have a test at 3:30 p.m. sharp. So kindly join back by 2 p.m. for the next session. It will be taken by Manoj Das. Attendance link is shared again in the chat box. You can fill the attendance and kindly join back by 2 p.m. Thank you.